Hello there, Internet. My name is Adam from Powerbelt 3D, and this is a very special video. You see, a few months ago, Michael Scroy reached out to me and explained that he had converted his Ender 3 into a conveyor belt 3D printer. However, he had a hard time finding a really good conveyor belt for his project, and ended up going down a lot of the same internet rabbit holes that I did when I first started prototyping the Powerbelt 3D Zero. I wanted to help, so I built him a Formula 32 conveyor belt exactly to the size that he needed. And as he and I talked more, I thought this would be a really good opportunity to help more people get introduced to 3D printing on a conveyor belt. He and I got on a video call to discuss the project that he calls the EnderLoop. I thought his perspective on making an affordable, accessible conveyor belt 3D printer would be interesting to a lot of people, so I recorded it so that I could share it with all of you, and I genuinely enjoyed talking to him about the project. If you want to tackle converting your Ender 3 into a conveyor belt 3D printer, we want to help empower you to do just that. So as of publishing this video, we have listed a conveyor belt specific for the EnderLoop project in our online store so that you don't have to worry about making a conveyor belt yourself. For the first week or so, we will even offer them as a discount just to celebrate collaborating with Michael on this project and helping conveyor belt 3D printers get more accessible to the world. All the links you could need to take on this project are in the description of this video. I did manage to screw up the video recording of myself while he and I were talking on the call, so I'll edit in something else in the video while I'm talking. And if you're watching this video and thinking to yourself, wow, this is all super interesting and has great information, like I hope that you do, then it would be really cool if you took 5 seconds just to tap the like button. It helps us know that we are doing something good in the world of 3D printing. Without any further delay, here's my chat with Michael about the EnderLoop project. Happy printing. All right. So again, thanks for joining the call tonight. Why don't you just kind of introduce yourself and tell us kind of your version of an introduction to the EnderLoop project?
Sure. So my name is Michael Scroy. I am a computer engineer by trade and a tinkerer in the night. And so, for this, obviously, we're talking about the EnderLoop, and I do a lot of 3D printing stuff. And one of the things I've been getting into recently was some belt printer understanding. And I started looking at the market, and a lot of the belt printers online are just like crazy expensive, right? Like not at all accessible to most people. And I started taking a step back and thinking that simply like it could be better. Everybody knows about Ender 3s, how reliable they are, and how cheap they are on the market. And so that's really just where I decided to start based on that information. So really what came out of that was the EnderLoop, and it costs about a third of the price of like the new like CR30, whatever that Creality has.
Okay.
Yeah.
The 3D print mill, the CR30, it's got 10 different names, right?
Yeah. Yup, that one. So price wise, about a third. And really one of the great things too is the mod flexibility. Ender 3s have been around for quite a while now. Pretty much every Ender 3 mod you can think of will work on this. So you don't have to like start over. You can just use pre-existing stuff.
So is yours still remote drive, or did you convert to direct drive?
It is a Bowden extruder. So it's not a direct drive. You could make a direct drive one work. There's no reason why you couldn't. I just didn't. Sure.
And how long ago did you start this project? I know we were talking earlier and you said you were just on the second version of the documentation, so it's been going on a while, right?
Yeah. We're probably looking at around 6 months at this point.
6 months? Okay. Honestly, I expected it to be more than that.
Nope, I stayed on task, was crazy focused. It probably took I would say about 2 months, maybe 3 to get out the initial version. Most of my time has been spent on the V2.
Okay, awesome. And I know it seemed like you were getting there a little bit, but why did you choose the Ender 3 as the starting platform?
I mean, really, a big part of it comes down to cost feasibility. Like I said, what I'm trying to do here is make this more approachable to like, the common user. And for the price point, Ender 3 is really one of the best you can get. Um, it's stable, reliable. Um, yeah, there's really no no issues with it. I mean, the only downside is that Ender 3s tend to have like less features, right? Because they're older.
Yeah, yeah. So when you look at the Ender 3, how far did you have to deviate from like the base model? Did you replace the control board, the hot end, anything like that?
Most of the main components are the same. I will say I cheated a little bit. The main board was swapped out because I managed to fry it while going through the first time. So um, I did go that route. I mean, nice upgrade too because I get the silent steppers. Um, but other than that, you can use all the base components really with it.
Okay. Awesome. That's so funny you said you fried the main board because I think when I was building the first prototype of the Zero, I probably fried 3 main boards. Just doing something stupid like pulling out a stepper motor while the motors were still energized, something like that. So I'm really happy that I'm not the only one.
It's so easy to
Um,
do.
but so it's possible to just use the stock main board, the hot end, all that. Really, I mean, this is definitely an oversimplification, but you're just kind of tilting the z-axis and adding a conveyor belt, right? Same heat bed.
Yep, same heated bed, same frame. Everything is basically like identical stock. Um,
Okay.
yep.
So then, what does your build volume become? Because one thing I noticed is that once you have an angled gantry, your z-axis becomes heavily related to your angle and how steep that is. Um, so how does the build volume change?
Yeah, so I I generally list it as somewhere around 110 by 200 by
Okay.
infinity, obviously.
Yeah.
um, so the biggest restriction that I found isn't the height. It's going to be in the X direction because I mean you probably know this. You have to rotate the print head 90 degrees, right, from like what would a standard orientation would be.
Right.
And so on an Ender 3, what that ends up looking like is the metal frame that holds the hot end and slides like
Okay.
back and forth, that little carriage piece.
Yeah.
That will get cut off by the gantry.
Okay. Yeah, I'm looking off screen at my Ender 3 and I'm trying to picture how things would rotate around. um, Still, I think 110 is a pretty usable X dimension. What I've found too is that once you have a single infinite axis, like you just rotate your parts 90 degrees if they're too big and all of a sudden they fit.
Right.
Um, so I've really liked that aspect of it. What about the Y dimension going up the angle? Is that still lead screw driven or did you convert it over to belts?
It's lead screw driven. I kept it that way because um, I didn't want to go overboard on modding this, right? I mean, the whole goal here is to keep it like easy, cost effective. Like if somebody's gonna just pick this up, and so it keeps the lead screw. I found that will decrease the speed, a decent amount,
Hmm.
but it's definitely still usable. The mods that I found online for Ender 3, some of those include using a timing belt for
Okay.
the y-axis, and that kind of goes back to where I was talking about like all the mods that already exist for the Ender 3, they still port over, and so if you wanted to remove that, you totally could.
Gotcha. No, that's a really good point. And when I first saw the project, that was the first thing that came to mind is the lead screw there. because it's going to slow things down. But you've probably seen the same thing where, and I don't see a ton of people talking about it, but printing on this style of printer, I've found at least, to be slower by nature than on a normal 3-axis setup, because on every layer, you have a first layer where you have to come in contact with the belt and make sure that it sticks. So ultimately, the lead screw probably doesn't slow things down that much.
Right. Well, and actually, a good point on that too. I mean, part of the reason that the lead screw is so slow is because you just can't spin it that fast, right?
Right.
It has a lot of friction with the mount that it's trying to move up and down, and so that's part of the reason. But since this is in a 45-degree orientation, you can actually increase the acceleration a pretty decent amount before you start running into issues with that.
Okay, awesome. So taking a step back here and looking more at the hardware and the printed parts, what are we looking at as a as a commitment if someone was gonna take on this project and try to build one?
Sure. So standard Ender 3 is about $200. You can get less or more. I think I found this one for like $170.
Okay.
It is possible to go less. The parts list, I would quote it somewhere between 1 and 200. It really depends on what you have on hand. The other thing I will say, as much as I tried to avoid it, there are a couple tools that you need.
Okay.
I mentioned in the instructions too, you can also just go to like a metal shop. Most of the stuff is not very difficult. And we can go into that a little bit more later if you want to, but
Absolutely. So you had custom parts made like at a local metal shop?
yeah, so there are two things really that you need tools for. Need is a strong word, I guess. You don't need.
Okay.
Highly recommend.
Highly recommend.
Yeah, you can work your way around it if you want to take that on too.
So part number one, rollers. So what I started trying to do was 3D print those, and I was getting good enough results when I'd run it, but when it sat for a while at full tension, they'd start to sag.
Okay.
And so if you really want to, you can use 3D printed rollers and just loosen the tension. However, would recommend against that. It's kind of a pain to level a belt.
Don't get me started.
Yeah, you get it.
Instead of 4, maybe 5 leveling points, all of a sudden you have 8 or 9, depending on the belt printer and everything. So it's so cool to talk to someone else who has like a homegrown belt printer and all of these struggles. But anyway, continue with the custom components. So rollers would be a great thing to have made separately, but 3D printed ones do work.
Yes. So the custom ones, all it is, it's still partially 3D printed. You 3D print the roller shell, and then get a steel rod. So really, the only thing you need for that is a Dremel and like a diamond cut bit.
Sure.
Just something to cut it down to a length that's manageable. Super simple. If you have it, like you can do it in like 15 minutes. If you don't have it, you can go to a shop and have them do it in like 15 minutes.
Yeah.
The other part that tools are good for is the hot end. So I mentioned before, it's a standard hot end. It's the one that comes with the printer. One thing you've probably noticed on belt printers is you have to extend the hot end down from the gantry, or the bar, I guess, that it's mounted on, not the gantry, but so that it doesn't.
The V-slot profile. That the
yes, yeah. So it needs to go down further. That way, it doesn't like hit stuff on the back end while it's trying to print. Like otherwise, it doesn't clear the belt or whatever. And so the part for that would be just a drill with like a titanium bit or something, so you can drill some lower screw holes. Otherwise, it works on the the stock mount for the hot end. So.
Okay, awesome. So, see, when you said tools, I was like, oh no, we're gonna need like a drill press. we're gonna need like a desktop CNC, but we're talking like drill, Dremel, maybe a hacksaw, just some basic hand tools that, I've had my Dremel for years and years. I barely use it anymore. But for every now and then, it's just like the perfect tool. So I would imagine a lot of people that want to take on a project like this, those are pretty easy to get, or find a friend that has a Dremel.
Yeah,
something like that.
Well, and like I said too, everyone's got a local metal shop. There's one somewhere near you. So you go in for like 15 minutes, they'll charge you a couple bucks, and you walk out with all the parts you need. Like, good to go.
Yeah. No, that's a really good point. My next thought was maker spaces.
Oh yeah.
Right? I would imagine that so many places have just small local maker spaces now where you could probably walk in and ask nicely and somebody would grab a Dremel and cut it however you want them to.
Probably, yeah.
Okay. And from the printed parts perspective, if you're not troubleshooting and like changing the design a bunch, which I'm sure you had to do, are we looking at like 1 spool, 2 spools of material? How long do you think it would take to make kind of like the essentials to do this modification?
I don't think I ever took a material measurement, so I don't have an answer for you there. What I can say, I did a total, part tally. 41 printed parts.
Okay.
Now, half of those are going to be done in like 45 minutes or less, probably.
Okay.
Another half of the remaining parts are probably going to be done in a couple hours, and the only ones that are long prints are going to be the roller, like outside pieces, whatever.
Okay.
Yeah.
Gotcha.
We'll call those the roller shells. Then you put the steel rod through the center. That doesn't seem bad at all.
Yeah, it's really a pretty easy build, once you've got the whole part list laid out.
Definitely. From a time perspective, if you have everything sitting in front of you, how long do you think it would take to disassemble and then reassemble as a belt printer?
I would probably place it, I don't know, like 2 hour mark, maybe.
2 hours?
I would say
Okay.
If you are a brand new user and you have not done this yet, and you pull all these parts together, I would allocate a day.
I think that's a very wise suggestion. Yeah. You always have to, at least I always have to remind myself, I can put together a power belt now in like 3 hours. And then like tweak and refine and make sure the Y end stop is where it needs to be. But for someone that's never seen one before, it's going to take a lot longer. Like, give it a day, give it a weekend, like, enjoy the process is how I like to think about it.
Well, and on that point too, I think it's good to note, for anybody who's like printing these, these parts and deciding to like put one of these together, maybe you've done like regular printers before. Maybe you've done DIY regular printers before. That's cool. This is completely different. Even like something as simple as the leveling process we talked about, right? Like, it's just way more complicated than you'd expect. And part of it is just not following the same train of thought that you would normally to like, get a printer working.
And I think that is part of what makes your project so cool, and what makes kind of the lowering barrier, I'm screwing up all my words here, lowering the barrier of entry to belt printers, I'm going to say globally, with iFactory and with the 3D print mill and with the PowerBelt Zero, people are going to be able to learn about kind of like this niche of 3D printing. And when you understand it, it's so incredibly powerful, being able to print things that are bigger than the machine itself and automatically just drop prints off the edge. It's been kind of locked away in the 5 figures price bracket for so long now, it seems like. And so I think similar to your inspiration for starting the project, was really similar to mine, where I just wanted to get it out there more, right? At price point that people could actually afford it and learn about it. And I think all of us in the greater 3D printing community will be able to really take it to the next level, is my hope, at least.
Right.
So looking at the project, if you had to identify like a single most difficult part as you were developing the EnderLoop, what would you say it is?
So I guess from a part perspective, the rollers were probably the most complicated,
Okay.
to be honest. It was something, I mean, I have so many rollers that I printed out. It was laying around the house right now. I've printed them in like, different designs. I've printed some with like railings on the side to keep the belt from moving left or right. I've printed crowned rollers. I've printed straight flat rollers. Printed them with different infills. And part of it too is like it takes so long to print it that
Yes.
the iteration time is just huge.
Right. Definitely.
The other thing, and this is more of a belt printer thing than anything else, I think, I'll keep coming back to it. The bed leveling was atrocious when I started. I had no clue what I was doing, and I was super confused. I'm like, this doesn't make any sense on a normal printer. I just like lower the print head to like 4 corners, good to go.
Yeah. I will say, so I love both of those, by the way. The actually fabricating the rollers, I remember initially I was like, all right, do I need teeth on the rollers like a GT2 pulley to like grab the belt correctly? So I'm glad we had some of those those same challenges and thoughts. And the bed leveling was so confusing for me too at first, but then once I got it, it almost became easier, because you have to level kind of only along the x-axis precisely, and then I found that the front 2 screws are a little bit more forgiving.
Yes. Yeah, that's absolutely true. And I think some of that comes down to like how tall and long. Like if you're maxing out the volume space, you're going to notice if the front 2 aren't level.
Oh, definitely. Yeah.
But for most people, like if you're just printing a bunch of Benjis, for instance, like no one's gonna know the difference.
Right. Was there any part of your build that was easier than you expected?
Probably the extrusion extensions. So
Okay.
I'll give you a little bit of context on what I mean there, because I know nobody's going to understand that when I say that. So as you know, printers use aluminum extrusion, right? That's the mainstay of the 3D printing realm.
Right.
So one of the things that I'd tried to figure out as I was going through this is, what do I do to extend the base? Because, I mean, like in Ender 3, the base is pretty small. I mean, it's pretty small on most printers that are styled like that.
Yeah.
And belt printers, they print longer, in the one direction, so you have to extend the base towards you somehow. And
Right.
so I was trying to avoid, getting more parts. And one of the things that I had a thought on was, what if I just, print aluminum extrusion just with plastic? It's obviously not aluminum anymore, thus my extrusion statement earlier.
Sure.
And so, but those just kind of worked out of the box. So I printed some like extensions. They're like 4x4 extrusion. They're about probably 6 inches long.
Okay.
Was that enough?
Yeah. I printed 2 of them, one for or 2 for each side.
Okay.
I guess. And basically everything on the base printer sits on the first set of extrusion.
Okay.
And then the second set is actually just for roller extensions.
Okay.
So
Gotcha.
everything fits on the base of the Ender 3 plus one set of extensions.
That is so cool because, again, I'm looking at my own Ender 3 off screen here, and it all kind of has such a nice small form factor with the power supply and the control board underneath and the LCD screen on the right hand side. And so it seems like, to your point, it'd be really challenging to extend those. But just, 3D print some faux aluminum extrusions and bolt it together and you're good to go.
Yep.
No, it's so nice that that's an easy fix. And then in terms of the conveyor belts, I just earlier today and yesterday filmed a huge announcement video for our new conveyor belts that I'm really excited about. But we started talking a few months ago, talking about kind of the challenges that you had in making conveyor belts and trying to buy conveyor belts different places. So tell us a little bit about that.
Yeah. So I'll kind of walk through my progression here. So when I started, I had looked at mainly custom stuff and DIY stuff. So on the custom stuff front, really the best solution that I could find was using BuildTak.
Okay.
I had heard of people you're probably familiar with the White Knight 3D printer.
Oh, of course.
Yeah. And they had all coordinated with BuildTak, and so they were willing to like custom make belts for them. However, the price point on those belts was like $300 or $400.
Okay.
And I'm sitting here trying to make this cost effective. Like, that's not going to work. Like, that's way off the table.
Yeah.
And so I started going down the DIY rabbit hole. I'd seen some stuff online about using it's called steel shim stock. So it's, for those who don't know, it's basically aluminum foil, but it's made of steel. And so cut that to length and then coat it in like tape, either like Captain or PET.
Okay.
And my results of that were all right. I did get some prints working, but we talked about this a little bit, Adam. But the adhesion was not where I wanted it to be.
Right.
I'd have prints that would just pop off for no good reason, like halfway through, and so that's actually when I reached out, and we started talking about some of the stuff here, and you had offered your new belt type. So yeah, I started using that. It's been a lot better.
Good. I'm happy to hear that. I went on quite a journey for about 28 months I started with like craft paper and different thicknesses of card stock and went with like aluminum foils and heavy duty aluminum foils and all this different stuff before like I came across my 30-second attempt at making a conveyor belt. So I'm super excited that I was able to kind of branch it out beyond just power belt. Because to your point, I had come across the same information about stainless steel shim, and it's just crazy expensive. And so in the context of trying to make belt printers more accessible for people, it just didn't make sense, right? To spend, I could go buy another Ender 3 or 2, or I could buy a single conveyor belt.
Right.
Something just didn't add up there. So I'm really happy to be able to kind of offer conveyor belts for the EnderLoop project. I'm super excited, and I hope we can get more people on board. And I believe, quoting no data whatsoever, the Ender 3 is the most popular 3D printer in the world.
Oh, absolutely. Absolutely.
It's everywhere. It's so cheap. It assembles very quickly. I recommend it to people all the time to like get their foot in the door of 3D printing. So I'm super thankful for your project and getting more people exposed to belt printing.
Yeah, absolutely. yeah, I that's really the goal here, right? Is to make it accessible for everybody, and so especially with with how widespread the Ender 3 is, like it's great for that.
I couldn't agree more. Any closing thoughts? Where can people find you online? I'll make sure to put a link to the EnderLoop project in the description so people can find that. But is there a Twitter or Instagram, anything that you want to plug? Now's your opportunity.
No, I am not a social media person, unfortunately. But yeah, you can reach out to me on there's a GitHub link for the project. Feel free to reach out to me there if you have any issues, concerns, thoughts, whatever.
Gotcha. Awesome. We will make sure those links are there, and hopefully we can get a lot more people on board with the project. And no judgment whatsoever on the social media thing. Sometimes I think life would be much better without it, but it has its perks connecting with people at times. So